is Alan Mullis with Mullis Mechanical. We've written a program for this stub shaft previously, and now we're going to go through the setup and operation of this part. Now, for demonstration purposes, I would like to point out we will be running this program dry, because otherwise we would get sprayed with coolant. So yeah, let's get to it. The first thing we're going to do, we're going to start our spindle. Now, on the lathes, you have to press and hold reset, and then press clockwise or counterclockwise to get the spindle to start. So press reset and clockwise, and our spindle is started. So we're going to go into hand wheel mode. We already have tool number 1 active, which is the only tool we're using in the program. And we're going to jog it over. The first thing we're going to touch off on is Z. Bring that spindle speed down just a little bit. Allow. Bring it in and touch. Take a few thousandths and shave the face. A few more. Okay. So we're going to go back to Z. We're going to click it over a few thousandths, and we're going to hit G54Z. And that's going to be our 0, so enter. The one thing that I would like to point out, and you can see that it modified our graphics there. One thing that I would like to point out is that I use the master tool method. And what that means is, this is tool number 1. Tool number 1 is G54Z0. So every other tool's Z0 is based off the cutting edge of tool number 1. So, for that reason, I do not press Z2 for tool number 1. For any other tool other than tool 1, in my case, I would press Z2. And that will zero that tool relative to your G54Z0, which is tool number 1. So we've touched off on Z, and we're going to do a quick check on our X just to make sure we're within the ballpark. Now this material is touching now. It's 1/434, which is about right. This material measured just under 1 7/16. So we're close. A couple of things I'm going to change. I'm going to go into my parameters, and I'm going to go to wear, and I'm going to edit that. And I'm going to add 10 thousandths to our X wear. Mine is set up in diameter. That is an option in your parameters, whether or not the wear is in diameter or radius. So we're going to go, so we've got -6 thousandths right now, and to add 10 thousandths to that, you go point plus 0.01 and enter, and it takes care of all the math. So that's that. Now we're going to escape back out, and we're going to hand wheel away. We're going to stop it. We're going to verify our program again. Okay, looks good. So we're going to escape out, run. Oh, home required. Forgot to home it. Well, that being the case, we're going to have to re-zero our Z. Okay, so we've rehomed our machine. Now we're going to go touch off on that face again. It should be fairly close because we park our machine at home. Yeah, we were pretty close. So we go back to Z, we go G54Z, and we'll just key it in this time for 10 thousandths. And there we are. And escape out. We're going to run, start, cycle start. She's close. Let's jog this out of the way. We can check out our part. Well, of course, it will look better with coolant. It did take on some heat, which is part of the reason that we went large on our diameter. But that was for the video. So we're going to cool this down, run the finish pass again, and then we'll bring in our final dimensions using the wear offset. Thank you for watching.